Welcome back. This is an Aleks homework video on calculating equilibrium composition from an equilibrium constant. All right, equilibrium, essentially, if you have a reversible reaction, anything that can go in two directions, you're going to go back and forth, making product, and then the product breaking down, making reactant again, back and forth, until you come to a place where you're not changing the amount of forward or backwards. So in this case, we've got three gases here, NO3, NO, and NO2, and there will be an equilibrium reached where there's a forward and backward reaction until it stops, and basically it equalizes. All right. So if you have too much product, it will go backwards, making more reactant. If you have too much reactant, it'll go forwards, making more product, and then it equalizes. So they're giving you some amounts, some molar amounts. So this is a molar quantity of gases here. They could equally have done pressures. They could have used pressures here, but they're using molar amounts. So that you're doing concentrations, and then asking for a concentration of one of these after equilibrium. Well, really the only thing that you're going to need to know is how to do an ice table. An ice table, remember, initial, and then change as you see, and then equilibrium. If you can do an ice table, then you should be able to do it. Normally, you'll end up doing a quadratic formula to solve it. So if you know how to do a quadratic formula, great. I probably would just do a quadratic calculator on the internet or whatever to find your two answers. Once you have the answers, you have to look at which one makes sense. If you have one that will give you a negative concentration, throw that one out. It's not physically possible to have a negative concentration. So normally it's the smaller of the concentrations that I would use, and then basically do some little bit of algebra. So let's work this problem and see how it works. So we have a chemical reaction here, and we see that it's reversible, and we have an equilibrium constant that they give us, which is great. So let's look at first just the equilibrium constant expression. If you're going to see what is my K is going to be equal in this case to the constant molar concentration of NO2 squared. You see we have a coefficient of 2 in the product, so that's going to be the square. It becomes the power divided by the molar concentration of NO3 to the first power times the concentration of NO to the first power. Okay, and we also know what that is. We're given that is 0.286. Right? What else are we given? Okay, we are given moles of stuff. Okay, we're given moles of NO2 and we're given moles of NO3. Remember that these brackets do not mean moles. These brackets is molarity, and molarity is moles divided by liters. So if you want to use these numbers to fill in one of these, you're going to have to divide by the amount of liters in the flask. And here you've got 500 milliliters, so that would be 0.500 liters. So you're going to divide that out. So I can go ahead and do that. We see that I've got 0.90 moles divided by 0.500 liters gives me 1.8 molar, and that's NO3. And then I'm going to do it again, 0.20 moles divided by 0.0500 liters is 0.4 molar NO2. Okay, so I'm going to use that. Now I need an ice table. Now that I know what my molar concentrations initially are, because an ice table gives you molarity at initially, molarity, what's the change in molarity, what's happening change-wise, and then what are you going to do at the end is simply going to be the sum of the initial plus the change. All right, so if I do an ice table here on the side, I break it up. So let's see, I'm going to do NO3 first, then I'll do NO, and then I do NO2, And so I found that I have 1.8 molar NO3. At the beginning, I don't have any NO, so that's 0. And at the beginning, I have 0.4 molar NO2. All right. Here's really the only hard point of this problem. What am I going to make X? I could make NOx if I wanted, because I don't have any, and so whatever I'm going to get could be my X. Most of the time, I would say most people are going to pick what is it they're asking for and turn that into X. All right, so for instance, they're asking for the equilibrium molarity of NO2. Probably most people would pick NO2 to be your X. All right, now do you see that it's going away because I have no NO? So in order to get some NO, I'm going to go from products, which is NO2, backwards to reactants. So I'm going to be moving away from products, so I'm going to lose some of my NO2 to make my NO. All right, that's what I'm going to do. So I'm losing it. So if this is going to be X, I'm losing X. So I'm going to say for every 1X I lose, how much am I going to gain? All right, so I go back to this, and I say for every 2 that I lose, I'm going to gain 1. Okay, so that means for every 1 I'm losing, because I have X here, that's 1X, I'm going to gain a half. So I say over here, this is going to be plus 0.5X, and it'll happen the other way too, because I have 1 NO3, so that means I'm going to gain 0.5X here. For every 1 I lose of the NO2, I'm going to gain 0.5X of the NO, and I'm going to gain 0.5X of the NO3. All right, now that is ice, so here's initial, here's change, and here's at equilibrium. I'm just going to add these together. So I'm going to have 0.4 minus X, that's my expression of NO2. I'm going to have 0.5X, that's my expression of NO, and I'm going to have 1.8 plus 0.5X, and that's my expression for NO3, right? Now what I'm going to do is I'm going to put these in to this. I'm going to put it into the expression. So what is my NO2? That's what I have at the top. So it's going to be 0.4 minus 2X squared over, now I need NO3. Well, what's my NO3? It's the first one, so it is 1.8 plus 0.5X, and then I need the other one, NO, and it's going to be 0.5X. Okay. All right. Now on my page that I did this, I have a whole page of algebra. I hope that I'm not doing you a disservice by not doing all this algebra for you, but essentially, I guess I can do some. Okay, so if I have that, you're going to round that out, and this is my second part. I had 0.16 minus 0.8x plus x squared over 0.9x plus 0.25 x squared equals 0.286. I bring up the bottom, multiply it, and then subtract. Okay, and when I get that, I end up with 0.9285 x squared minus 1.0574 x plus 0.16 equals 0. And you're going to do the quadratic formula. Or you can do like me and just do a calculator on the internet. You can find a quadratic calculator. It saves you 15 minutes of doing it. I can do quadratics. You just have to do it. In any case, when you do that, you're going to get 2 answers. The 2 answers I got was x equals 0.95917 or x equals 0.179656. This one cannot be right, the top one, because if you look back up to this, you can see that 0.4 minus x is going to be a molarity. Well, you can't have a negative molarity because you can't have a negative concentration. So that's practically impossible. So I'm going to use this one, and I'm going to substitute this in for x and then subtract it from 0.4. Okay, when I did, I had the NO2, which equaled 0.4 minus x, okay, and so when I put that in for x, I get 0.2203, which gave me, they wanted two significant digits, gave me 0.22 molar. And that is the answer that I got for this one. So I hope that I helped you. I hope you're doing well.